Here we have this rectangular area, and it's sitting in a magnetic field, and then we're spinning it around in this way with 877 revolutions per minute. We're trying to find the maximum EMF. Now, the EMF is supposed to be the time derivative, and I suppose we could put the negative in there, although we're looking for a magnitude as usual, but we'll go ahead and put that flux in there as well. And yeah, so let's go and try to figure out what flux means again. That's going to be the integral of B dotted with dA. And we already know that B is constant, so we'll just pull that out of the integral. And then technically we'd be left with like dA, and then there should be like this cosine thing there. This is still what flux is, so let's not get confused. And if we're going to integrate dA, that was a really easy one. It's just going to be length times width, so, you know, we can just get rid of that. We'll just call it BA. The area is not changing. And then we'll just be left with cosine theta. So this is going to be the answer to the flux just by itself. But what is cosine theta? Let's not worry too much about that. Let's just focus more on the derivative now of BA cosine theta. So, right, I guess we do have to know what theta is, because we have this. We have the 877 revolutions per minute, and if we'd be able to look at our little mechanics cheat sheet, and we'll be able to remember that revolutions per minute is supposed to be multiplied by 2 pi radians per 60 seconds, and that would give you the radians per second. So that would give you like theta t if you would want to do something like that. So revolutions per minute is 87 there, divided, or so when you multiply that by 2 pi over 60 seconds will give us like, it would be something like the flux is BA cosine of 877 over 30 pi. So now if we were to try to take the derivative of that, well, derivative of cosine is supposed to be sine, and we'll put 877 over 30 pi in there. Then we'll kind of multiply that. And remember, I'm doing magnitudes here, so I'm not even worrying about the negative signs. But we'll multiply that by 877 over 30 pi at the end, and we'll still have the BA over here. Okay, so this is kind of what the EMF is. And now what's really important is to remember that we're looking for max. So if that was the max, this would have to be equal to 1, because the sign can only go from -1 to 1, and the maximum is that. So technically, let's just get rid of the sign, and we'll be left with the EMF is supposed to be equal to BA times that. So let's do that. The answer was going to be that component times the B, which is 4.11, times the area, which is just these two things, 2.6, -2, times 26.7, -2. And then let's now multiply this by 110. Let's not forget that. 110. And so we should get the final voltage. This is the maximum possible voltage, something like 80/48. Nice.